All right, let's begin here. And hopefully you weren't bored. You kept yourself amused by working on some of these factoring ones. Now just refresh your memory. So here, when you're doing this, you asked yourself, now what two numbers that will multiply to negative 15, which is 3 times negative 15. So you have to multiply to negative 15, but add to negative 14. And the same idea here. This times this, what two numbers will multiply to that, but add to 8. Anyways, this will come up later, so I thought it'd be good for you to practice that, like we did way back beginning of this class. Oh, just so you know, your very last homework assignment, it's actually going to be a written one. In fact, here, let me just click on this one. It's just not very conducive to using web work. So I'm actually assigning these 4 problems from the textbook. Let's get back here. And you'll see that in today's checklist, open up today's checklist. In the checklist, I actually put them in the checklist for you. So you don't have to go into the textbook and look them up. Just get your checklist and the 4 problems are right there. So I'm going to be working through problems just like this today. So I'll be showing you exactly what you'll be doing in this homework here. Okay. And this is your last homework assignment. And of course, this is where you've had one other like this where you will scan these and put each scan onto its own page in a document. And then you'll go over here to submit it, where you click on this. And then you scroll down, click on add submission and submit that one document. So please send me one document. Please don't send me 4 images because then I just have to go and put them all together. And I really appreciate it if you would do that for me. Okay, let's get back here. And yes, tomorrow, Friday, will be a review session. So this is the last real lecture of topics to be covered. And you'll notice that I broke it up into 2 parts. I felt it was a bit much for one. And what I really wanted, and just so you know, that little outline I was using yesterday, I got that posted up here. And I have an outline today, and I'm going to post that up after the class. I like to wait till after the class because that way, if I catch any typos, which is bound to happen, I mean, I just typed it up this morning, I can fix those before posting it. Let's see here. So I am going to open up. Yeah, here's my little outline here. So this was what my hopes were, is that between last class and this class, at least you got started on the part 1 homework. So that way you've already got under your belt some experience. So now you're already comfortable with the concepts of the domain, finding the vertical asymptotes, because we're going to build on that. So after finding the vertical asymptotes, we're going to focus on knowing the local behavior. Now, remember, end behavior is what happens at the ends, the far distant ends of a function. Local behavior means at this particular place, like around a vertical asymptote, what's happening. So that'll be one of the bigger concepts we'll be going over today. And that you already know what removable discontinuity is, but we'll get practice with that. Horizontal asymptotes, at least you're familiar with that. And don't worry about slant asymptotes. See, the problems I gave you, there's no slant asymptotes. Hey, look, we got to pick our battles here. So rather than cause any extra confusion, I figure you got enough on your plate as it is. And it turns out slant asymptotes aren't that super critical for you to be familiar with. Everything else we're doing, yes. But slant asymptotes, we can let that one slide. And so that really does remove a bunch of stuff off your plate that you'd have to be studying and learning. And X-intercepts, Y-intercepts, you're probably pretty darn clear with that. All right. So with that under your belt, what we're going to be basically doing is, well, like you saw in the that checklist of problems, you're going to look at that rational expression and be able to make a rough sketch of it. You know roughly what it's going to look like. Not exactly, but roughly. But first thing we got to do is we got to gather a bag full of clues. And that's what this little 8-step procedure, actually it's just 7 steps. The 8th step is actually making your sketch. So this is what I'm going to be following. Now this is, of course, this is right in your textbook here, but in my outline, I'm elaborating a bit more. Okay. So for example, let's just run through this, but don't worry too much about it. You're going to see me applying all these concepts as we work through some problems. But, first thing we'll do is, hey, just do the easy stuff first. Nothing's easier than finding the y-intercept. That's just where you replace every x with a 0 and see what the function is. Next thing, because you're so familiar with it, is to find the x-intercepts. Now, what you've already been introduced to is that what you look at to find the x-intercepts is the numerator, because that is what tells you where the x-intercepts are. You just, where does that numerator equal 0? And that is your x-intercepts. Unless, of course, there is one of them is a whole. Okay, so if you've got the same factor up in the numerator as down the denominator, for example, like here, number 3, see how, first of all, let me go over this terminology, make absolutely sure we're clear on this. When I say factors, you know what I mean. See that x minus 1? That's a factor. See that x minus 2? That's a factor. We got 2 factors up there in the numerator. And we got, actually, we got 4 factors because we got 2 of these x minus 3s and this one here and this one here. So we actually got 4 factors down there. Factors means they're multiplied together, and things that are multiplied together, they can actually divide out. So this x minus 2 could be divided by this, and that would equal 1, and this would simplify. Okay. But when you have that happening, then instead of having a vertical asymptote at x minus 2, you're going to have a hole. Not a donut hole, but a hole. The fancy name the textbook gives it is a removable discontinuity. That certainly sounds more impressive than a hole, but whichever terminology you prefer. Okay. So first, we'll find the y-intercepts, easy peasy. Find the x-intercepts. Okay, and then going down here, we're going to find where the numerator is 0 there. And notice where we have those holes. Oh yeah, I kind of skipped over 2 here. Idea with 2 here is where you have to factor. That's like what we had going on over here. If this were up in the numerator, this was down the denominator, first thing you got to do here in number 2 is factor the darn thing. Now here in number 3, we can see it's already, this one's all factored now, after step number 2 had been done. Okay, now that you got that, so not to insult you anyway, but just make absolutely sure you remember this is the numerator, this is the denominator, these are the factors. So it makes sense, we say for factors in the numerator, not common to the denominator, that would be like x minus 1, because there's no x minus 1 down there. Determine where each of those numerator are 0. And you're going to find the x-intercepts. So let's go, whoops. I didn't mean to do that. Let me change this so it doesn't jump on me like that. Then for each of those x-intercepts, we need to find the multiplicity. Because remember, if it's to an even power, that means that x-intercept, the graph is going to bounce on that x-axis. So you need to know that. Does that graph cut through the x-axis or does it bounce on it? And so that's why you need to know if it's even or an odd multiplicity. And you've worked with that before. In fact, that was back in chapter 3.4 when we first learned about that. Then what we do is now we look at the denominator so we can figure out where those vertical asymptotes are. So if you had, hopefully you've had some experience with this. But here's what we're going to add to it that we weren't worried about last time, because I wanted to break this up in parts. Now, let's suppose so you're looking at the multiplicity of that factor. So these are factors. So see this factor right here, x minus 3? That's a multiplicity 2. Now, this x plus 4, that's a multiplicity 1. So that's what they're talking about there. Now, if it's a multiplicity, say, of 2 or any even multiplicity, so if this vertical line is your vertical asymptote, this is what your graph is going to do. It'll either go, up, both will go up, or possibly they'll both go down. But this is from your toolkit function. Do you remember way back in chapter 1.1 when they gave you those toolkit functions? It's because these are the ones that are worth remembering. And 2 of those are these right here. So this is what 1 over x squared looks like. So whenever you've got this multiplicity of 2 going on down the denominator, it's doing just like what 1 over x squared does. So this means I need to know this, because if wherever I have my vertical asymptote, is my graph going to be going like this, or possibly they're both going down? If it's odd, like right here, then it's going to do this, where it's going to go up on one end and down on the other, or it could go up here and down there. All right. So it's either this or the opposite of that. In other words, flipped over the x-axis, what you see here, and the same thing there. All right, so this is kind of new to you. So this is kind of what we're going to be focusing on. That'll take a little getting used to. And so then after you've done that, for the factors in denominator, come to the factors in numerator, find those holes. Now, usually instead of doing that down number 6, I know it's up to you. I usually do that when I was figuring out the X-Intercepts and saying, oh, wait, this is an X-Intercept, it's a hole. But if you didn't do it up there, then you would take care of it here. And now number 7, should be familiar. This is where we determine the horizontal asymptotes. So this will hopefully be a review for you. But after you've gathered all these clues here, then we can use that to make the sketch. And that's the part that it's really helpful for you to watch me do that with some of these, so you get the hang of it. You know where to start and how to take those clues and figure out how to use them to make the rough sketch. All right. So, but you have this for handy reference to refer back to. So what I'll do here is, hey, let's just do this one right here. Let's get this out of the way, and let's get a piece of scratch paper up here. Move that over there. Now here's something. Now I've got here, since I'm going to be making a sketch, let's hit that focus. I got a piece of graph here, but I've got room to work here, so I can do my work down here, and then where I got all my clues, and then once I got that, I can go up here and use this to make my sketch. So I got a copy of this up there on the Moodle website if you want it. You don't have to use it. I mean, you can do a rough sketch on binder paper if you want. But if you haven't used up all the ink in your printer and you got some paper, you just might find this is really convenient. So I'll do my work down here. Now we're starting off easy here. We'll say that we did all that hard work and we got this darn thing factored over here. And so let's just write down this little function. F of x. And down here in the denominator, I got x plus 2. And I got x minus 3. And that's squared. So this factor is of multiplicity 2. This factor is multiplicity 1. Then I have this one, which is a multiplicity 1. And then let's get our numerator in there, x minus 1, and x plus 2. Oh, and no cheating. Now once I'm done and I have my rough sketch, then I'll graph it on my calculator. But until then, no doing that. Okay? Because you're not going to learn anything that way. Because what we're doing here is we're getting comfortable and understanding these nuances of these ratio expressions, and we can foretell what they're going to look like on the graph. And we know what aspects of this, cause those things to happen. So it's deepening your understanding of these, and you're only going to get that if you, work through these like this. Now let's do the easy part. So let's get our y-intercepts. And by the way, if you're wondering, hey, how do you even get started once you get the clues? Well, let's get all our clues together, then we'll put that together. So all I got to do for this is find f of 0. In other words, all I'm doing is I'm going to throw a 0 in my function and what spits out. That's all it is. So if I do that, so if that were 0, this would be a minus 1. Put a 0 in there, this would be a positive 2. 0 in there, that would be a 2. 0 in there, this would be a negative 3 squared. A negative 3 squared is a positive 9. The 0 there is a 4. And so I'm going to have here negative 2. And see, 9, 18, 36. I think that's 72. I better double check myself so I don't make a dumb arithmetic error. Yeah, 72. And then, of course, that simplifies down to 1 over 36, or negative 1 over 36. So that's pretty darn close. That's just below the x-axis. So we know that. Now let's do the next thing, which is find our x-intercepts. So for this, what we do is we look at our numerator, and you're thinking 1, negative 2. But remember, this is a removable discontinuity. This divided by that. So x minus 2 is actually going to be a whole. So my only x-intercept is at x equals 1, which makes that 0. And so right here, right, and I should make a note here. And what's the multiplicity of this? Multiplicity of 1. I'll circle that. And I'll circle my clues so they're easy for me to find. Okay. So I got my x-intercept. And why don't here, even though it's listed as number 6, let's also address this x equals minus 2 is a, now if you prefer, instead of saying whole, maybe you would prefer to say removable discontinuity. So feel free to do that. This might not be classy enough for you. All right, so we got that. Now let's see. So notice that when I got the multiplicity, that was step 4. So now we're moving on to number 5, where we're going to be looking at the vertical asymptotes. Let me move this so you can see where we are in these steps. So let's look down here. So this is what we're looking at for vertical asymptotes. And so I'm concerned with this one and this one. You say, what about that one? Well, remember, that's a removable discontinuity. So that's going to be a whole. So don't expect it to be a vertical asymptote. Okay. Now, so I'm going to have a vertical asymptote. Oh, I just noticed. Got a comment. Oh, yeah. Someone asked, how do you know minus 2 is a whole? Maybe I answered this after yesterday, but notice that this divided by that. When you ever have the same thing up here as down there, that's what makes a whole. Now, that's a new thing. probably saw that for the first time your whole life last class. So, and that'll still take some getting used to. But the nice thing is, this will be verified. And I think hopefully at least on some of these, should be able to find a nice viewing window with, only with the newer calculators do you have a chance of it actually showing you the hole, but it's not going to be obvious by any means. Okay, so let's get to my vertical asymptotes. Hey, let's do this one. So that happens so if I set this equal to 0, I'll have x equals 3. And notice that it's a multiplicity 2. So here's what I'm going to make a note to myself. So either, now going over here, see how that means that it's going to go to infinity in the same direction on both sides of the asymptote. So either this is going to happen or it's going to go this way. It's one or the other. Okay. And you say, well, how am I supposed to know? Well, see, that's what I'm going to show you. That we're just getting a bag full of clues here, and we will be able to figure it out, and we'll be able to deduce it, in other words. So at this is going to be like that. Okay. Now we got the other vertical asymptote. And that's at x equals -4. And that's a multiplicity 1, I hope you notice. And just like we see over here, that means this is what's going to be happening. So notice that either you got a multiplicity of an even or an odd. So at these asymptotes, it's one of these scenarios. It's one or the other. So it's not too complicated. Okay? So if you just remember, when it's even, it goes like this. If it's odd, it does that. And of course, if you know your toolkit functions, then it's even easier to remember. So that means either one of these will happen. Either it'll go, swoop up like this on this end and then swoop down on this end, or the opposite of that. It'll swoop up on this end and down on that end. But it's going to be either one of those. Now our step 6 down here, we already found our discontinuity here. So now let's do, this one should look familiar, is finding the horizontal asymptote. So what you got to do here is, and this is the way to think about it, is, okay, now what happens as x goes to infinity? And you say negative or positive? Both, okay? Just as it goes to infinity, we want to see what happens to your function. Say, well, I'm going to put a squiggly equal sign and say approximately this will happen. Now, this would be super easy to see if if we saw this before it was factored. But you should be able to see this. You can imagine multiplying that out. What's the highest power you're going to have? X squared. And there's no number in front of those x's, so the leading coefficient is 1. And same thing here. You got two of these x's here, that x, that x. If you can imagine multiplying those out, you're going to have x to the 4. It's got 2 here, 1 there, 1 there. And you don't see any coefficients in front of those x's, do you? Just 1. So that's how we know that. So what does that simplify down to? Well, these two x's will divide out down here, and this will simplify down to 1 over x squared. All right. Now, as x goes to infinity, what will f of x approach? Well, as this gets bigger and bigger and bigger, this is going to get closer and closer to 0. And that's how you know that your horizontal asymptote is y equals 0. All right. All right, so there's our bag of clues. So what I'm going to do is I'm going to get my little ruler out here, and I'm going to go ahead and let me put my little axes in. Since I got a graph, I might as well use a ruler so it keeps things. And actually what's sort of good to do is I'll erase some of these so you can see it's dashed. Because you see, I got a horizontal asymptote here on the x-axis, so I kind of like to remind myself of that. So if I thought ahead, I wouldn't have drawn out all the way. So then I would have done a little dashing here just to remind myself. Oh yeah, it's a horizontal. That's why I usually like to do this. Because I want to remember that. It's important to remember that you've got a horizontal asymptote. And let's see, so I'll put it, that's my x-axis, so let me put my y-axis in here. Now, what I'm going to do is I'm going to put in my asymptotes. So, well, this will make it a little more. So I'll use my red pen because, you know, you can't mess around with asymptotes. You really want them to stand out. Now, don't worry, in your homework, you don't have to use color like I'm doing here. And you don't even have to use the fancy graph paper. I'm just saying it just makes it a little easier, a little more festive. Now, let's get those vertical asymptotes. So I've got one at x equals 3. So that's 1, 2. So I've got one right there. So let's put that in. And the red pen really makes them stand out. So when it comes to vertical asymptotes, the graph cannot cross it. You know, no messing around with a vertical asymptote. Horizontal asymptote, it can cross that, all right? But the vertical ones, no way. And let's see, our other vertical asymptote is at -4. So let's see, go 1, 2, 3, 4. And knowing these skills is helpful because if you were looking at this and you'd say, oh, well, I should have vertical asymptotes at -4, 3, and -2. And if you looked at the graph and you'd say, hey, how come there's no vertical asymptote there? And you'll say, oh, that's right. It's a removable discontinuity, so it'll be a hole instead of that. And usually with technology, that doesn't always show you the hole, but you need to know it's there. All right. So once you got these vertices in, that's what the first thing I like to do is get that in. Then I plot in the intercepts, the Y-intercepts, the X-intercepts. So let's see now. We have got Y-intercepts. That's just below the X-axis. So there's 0. So it's just so we know it's below. That's close enough. And get 2 axes, just so we know that we're below that horizontal asymptote. And then we've got our X-intercept at x equals 1. Let's see, that would be right there. Now, here's the other thing I like to do. You see the little notes I made here? So over here at x equals 3, I got to figure out, now, is it going like this? Or is it going like that? It's one or the other. And then over here on this one, this is what I'm wondering. I know it's going to be either going up like that, down like that, or the other way. Okay. Now, so for example, so here's the thing that, you know, it takes a little skill and practice is, okay, what do I do now? Okay. Well, for example, over here, I really don't know what to do yet because I got this horizontal. I really don't know whether it's doing this or that. I don't know. Same thing over here. But working with the intercepts, that's usually, well, is the safest place to start. Now, I do know this. These are going to connect. Oh, and also it's helpful to know Now, it's important to know the multiplicity of your X-intercept. Ours is a multiplicity 1. Now, if this had been multiplicity 2, that means it would have bounced off of there. It would hit there and go down like that, and that would tell me, oh, it goes down, then I know this goes down, and I would figure the rest of the stuff out. So, not noticing the multiplicity can really mess you up. So, multiplicity 1 means it passes through there. So, these are going to connect, and it's not going to bounce on the X-intercept, it's going to go through. So the only thing you can do now is go up here. So how do you know it doesn't go up and down? Because that's the only X-intercept. If it went down, there'd be another X-intercept, and there isn't. That's the only X-intercept. So that is how I know it's got to go like this. Well, now that I know that, I know it's this one. So therefore, it has to be going like this. Then what does it do? Well, it's got this horizontal asymptote, so it should do something like this. You say exactly like that? Well, you know, roughly. Remember, it's a rough sketch. But you see, I had to really start with my X-intercepts, and you know that it can't go that way because you can't have another X-intercept. Now, if this had been a multiplicity 2, it would have hit that and bounced down and gone down. And then I went on that, went down like that. All right. Now, which way do we go, George? Well, let's see here. Is it going to go up or is it going to keep going down? Well, to go up, it would create another X-intercept. Well, we only got one X-intercept, so that means the only thing it can do is go down. Now, remember, we do have a hole here at -2. So, but that's why I do this in pencil. So usually what I do is I'll draw this in and then I'll erase my little hole and put a circle there. But it's going to do something like that. So now I can see where my line crosses to, so that way I can do my little erase and put a circle. So there's my hole, my removable discontinuity. So we did not have a vertical asymptote, we had a hole. Why? Because it divides out. Okay, now that I know it goes down like that, I know which one of these it is, don't I? Oh yeah, it has to be this one. So that means it's going up on this end. And you got a horizontal asymptote. So it does something like that. And that's your rough sketch. Okay? So the trickiest part of it all was after getting all your little asymptotes in, it says, okay, where do I start? Well, I couldn't really put that in to start with, and I couldn't figure this out. The only thing I could do was start with my X-intercepts, and then from there I could figure out I only had one way to go because of my limited number of X-intercepts. Oh, and then of course, you can always check your work, and you should. Just don't do this first, that's all. Now you do got to be careful because you don't want to enter it in wrong and think you did this wrong when you did it right. That would be discouraging. So double parentheses. So what I'm doing is this. All right, otherwise it's not going to work right. So there's my first parenthesis, and then I'll do my X minus 1, and then X plus 2. There's my closing parentheses around my numerator. Then I hit the divide key. Then 2 of these left parentheses. Then I'll have my X plus 2. Then my X subtract 3. And that's going to be squared. And then we'll have our X plus 4. And don't forget 2 closing parentheses. And let's just do zoom and 6 for zoom stat. And hopefully I answered the question. Someone was asking, how do I know the direction and way the vertical asymptotes will go? And so hopefully that when that question came up, you noticed, you know, what I was describing here, and that's described here. So this is how you know, by noticing the multiplicity, because the multiplicity is what tells me if multiplicity is an even multiplicity, then I know it's going to do one of these. The multiplicity is odd, it's going to do one of these. So, so that's the thing that's going to take some, this is what's new to you. So that's going to take some practice, getting used to that. Oh, so let's take a look here. So it's looking pretty good. And if you wanted to, you don't need to, but you can press second and then draw and select vertical. Then go over here to the -4. And if you want to see where it says style, that means if I press this button, that's what that's referring to. I can change the color, red, like, oh, how about magenta? I can hit the down arrow key until I get to OK and hit enter. And then if you want to do another one, you can go over here to the 3 and hit enter. All right. Oops, let me hit graph there. So you say, yep, that looks pretty good. But you'll notice that, hey, boy, it looks like it kind of hung closer. Well, look, come on. This is just a rough sketch. I'm doing pretty good. I wouldn't know that it clings on like that. You wouldn't know that. But you knew approximately what it's doing. And so that's the whole point of all that. So this is the sort of thing you'll be doing. The homework is first show this work, all your clues, and then use these clues to piece the puzzle together. All right. Now, so what I encourage you to do is you can do the same thing with example 11 on page 291. I'm going to do a couple from the textbook, not the ones in your homework, of course. I'll go over here. Let's get down. Make this a little bigger. So how about let's do number 43, because that's the ones where I had you factor those. Oh, maybe I should get out a piece of binder paper first for this. Let's see, where did I put that? Oh, there's my binder paper. Let's get a sheet of this. So let me just get these factored. We'll just go down memory lane here. And so once again, I'm doing 43. So when it comes to 3x squared minus 14x minus 5, what multiplies to, and of course you do 3 times minus 5, which is negative 15, but also adds to the middle term, negative 14. And so if you look at that, let's see now, what could that be? And how about negative 15 and 1? Let's multiply to that and add to this. And so how we did that was we just simply replaced this with that. So I can do a minus 15x plus a 1 positive x minus 5. And then we just factor here by parts here. So what's the most I can factor out of those two? I believe a 3x. So this would be an x, and that would be a minus 5. So that multiplies out to this. How about here? Well, can't factor much out of there. I think a 1 is about the limit. And then I have x minus 5. Oh, what a coincidence. Look at that. No, it's not a coincidence. Of course it works because you found the two magic numbers. So this is 3x plus 1, x minus 5. So that's that one factor. Let's go do the other one, which is 3x squared plus 8x minus 16. So what multiplies to, so 3 times negative 16. I believe that's negative 48, but I am going to double check myself. I'm not taking any chances. Yes, negative 48. But adds to 8. And what could that be? And how about 12 and negative 4? Because that times that is this. Add those together, it's a positive 8. So here we go. I'll do a 3x squared. And we're just going to replace this with those two. And maybe I'll just do the plus 12x minus 4x minus 16. And what's the most I can factor out of those two? A 3x. So this would be an x plus 4. And what's the most I can factor out of those? Well, how about a minus 4? And that would be an x plus 4. See how this times this is a negative 16, this times this is a minus 4x. So that becomes, I'm basically factoring the x, this factor. Remember, this is a factor. I'm going to factor that out. And so I get 3x minus 4 times x plus 4. All right, so that's it, all factored out. So since I got that figured out, I'm going to go to my nice little paper over here, and I'll write it out in its factored form. And let's see, we had 3x plus 1 and x minus 5 and 3x minus 4 times x plus 4. So sometimes we got to do that ourselves, all right? So, but good practice in case you ever wondered, when am I ever going to need that factoring? Well, now you know. So let's find f is 0, which is our y-intercept. Well, let's see. If that's 0, this becomes 1. That would become minus 5. This would become minus 4. That would become 4. And so we would have negative 5 over negative 16, which is 5/16. So our y-intercept is 0, 5/16. So a little less than a half. So it's above the x-axis, but just a little bit. So we know, so that's one of our clues. Now let's look at our x-intercepts. Oh, let's label this y-intercept, just to make super clear what it is we're doing. And we're now going to do the x-intercepts. Do we have any holes this time? Let's see, do I have an x minus 5 down there? No. Do I have a 3x plus 1? No, nope. Okay, so we don't have any holes this time. So that means that we're going to have two x-intercepts when this equals 0 and that equals 0. So that'll be when 3x plus 1 equals 0. So subtract 1 from both sides. So x is a negative 1/3. Or you can see that when x minus 5 equals 0 or x equals 5. So we got those two x-intercepts. So what are their multiplicity? Well, they're both to the first power, excuse me, up here, first power. So let's make a note, multiplicity of 1. And once again, why am I keeping track of the multiplicity of x-intercepts? Because I want to know, is it going to just shoot right through the x-axis, or is it going to bounce on the x-axis? We need to know that. So both of these are going to cut right through the x-axis. They're not going to bounce. So that's why that's important to know. Now let's find our vertical asymptotes. And so that's where we look at our denominator. So we got 3x minus 4. You got to see where that equals 0. And that gets the vertical asymptote so that this never, ever happens, because we don't want to ever have division by 0. And also when x plus 4 equals 0. And so you don't find any of these up here. So these will both be asymptotes. Once again, we don't have any holes this time. Okay, so I got 3x equals 4, adding 4 to both sides. So x is 4/3. And over here, x is a -4. Now, what's the multiplicity? Just 1. So let's make a note of that. Multiplicity of 1. And so what multiplicity of 1 tells us is this, that for each of those vertical asymptotes, it's either going to go like this or it's going to go like that. In other words, they go in opposite directions. It's one or the other because the multiplicity is an odd number. So this is what happens when you have 1 over x. And also wouldn't hurt to do this. Well, actually, it's part of our horizontal asymptote. The nice thing about this sheet is, this is usually enough room to get my clues done, and then this is usually enough to get my sketch done. It's just like the perfect thing for this assignment, in my humble opinion. So let's see now, what happens as x goes to infinity with this function? So what you do is, now remember, is that the leading terms take precedence. All the other terms sort of diminish in importance as x gets bigger and bigger and bigger. The higher power terms are the ones that take dominance. So that's the end behavior we're talking about here. So that's why I use this squiggly equals. I say, well, let's see now. Now, of course, over here, this is easy to see now. You can see your leading terms very easily here because we started out with that. Oh, so that's just basically just 3x squared all over 3x squared. Those are the leading terms. And what does that simplify down to? 1 over 1, which is 1. That is how whoops, excuse me. That was out of the view there. So this is how I know we have a horizontal asymptote at y equals 1. So once again, what we're talking about here is the end behavior, way at the far distant ends of the graph. What we're talking about here is the local behavior. In this local position, right around that asymptote, what's happening. So when they talk about local behavior and end behavior, get familiar with those terms. All right, so I got my clues. Let's piece this thing together. So let me get my axes in. Let's get this one in. And let me get my red pen. Now let's get these asymptotes in. So we've got our vertical asymptotes. See, 4/3, that would be 1 and 1/3. So here's 1. I know that sort of looks like 1/3 there to me. So let's put that one in. And our other one for vertical asymptotes is at -4. So let's see, 1, 2, 3, 4. That would be right there. And then we'll put in our horizontal asymptote. So it's not at the x-axis this time, it's at y equals 1. So that would be right here. So we'll get that one in. All right. So like to get those in. Then what I do is I put in my intercepts. So we got here X-intercept 5/16. Well, that's about a half here. And so the important thing is it's below this horizontal asymptote. So note that. So we got that point. And we got two X-intercepts. I've got this one at -1/3. Let's see, that's 0. Oh, no, that sure looks like 1/3 right there. And another one at 5. So let's see here. 1, 2, 3, 4, 5. Okay. Oh, and also remember this. So at these vertical asymptotes, I know one of two things happens. Either it's going to go up on this side, down on that one, or it's going to be the opposite. Up on this end, down on the other. And the same is true over here. You know, when you're first learning, it's kind of helpful making these little notes to yourself. So you're not having to keep that in your brain. And when I determine which one it is, I circle it. I say, aha, so it's that one. So let's see here. Now, and the other important thing is it going to bounce or cut through this X-intercept here? And I can say, well, it's a multiplicity of 1, so it's going to cut through. So I know these will connect. It's not going to bounce, and it'll cut through like that. Now, is it possible? So is it going to go up like this or down like that? Well, it can't come back up again because then there would be an X-intercept there. And we know there isn't. These are the only X-intercepts. So the only thing left for it to do is to go cozying up to like that. Well, if it goes down like that, then I know that this is what's happening. So it's going to go up on this end. And then what does it do? Well, it's got a horizontal asymptote. So it'll cozy up next to that. And, over here. So what's it going to do? Is it going to go back down again? No, it can't do that because there would have to be an X-intercept somewhere here, and there isn't. These are the only ones. So the only thing it can do, you say, but you're cutting through a horizontal axis. Hey, it happens. But we never cut through a vertical axis. But it has to cut through. It can't come back down. And it can't go like this because then it cut through a vertical axis, and you never do that. So it goes up like that. Now, how about over here? So I've got this, and it's multiplicity of 1, so it's just going to cut through. And I've got these asymptotes here. So that means, well, the only thing that it could do is this. Okay. And if you punch that in, that's exactly what will happen. All right. Well, I was able to work through a couple of these, and hopefully that'll give you enough experience and practice with that. But first, you got to get your clues. But the art is figuring out, all right, well, how do I piece them together? So hopefully you notice I put in my asymptotes. And after I did that, I find it helpful. Oh, by the way, when I had this, I knew this was going down. So that, okay, so that's how I knew it was this one. But then going to the intercepts, I can figure it out. Doing all those deductions like you heard me do. All right, well, Bob, I went a few minutes over here. And you probably got places to go and things to do. And so tomorrow's our last class, and we'll have it be a review session. So there's things you'd like me to go over, well, bring them to class. Okay, so we'll see you Friday.